Good day, everyone, and once again we're back together. Well, on this very cold day, I hope that you're keeping warm. Right, of course, I know many of you are busy with your exams and preparing for your physics. All right, so let's get right into it. If you haven't subscribed, please just make sure you're part of this family. All right, otherwise you can always also join in as a member in this channel. All right, let's get into the multiple choice, and this is from the September KZN exam. Right, let's get right into it. Right, let's start with the first question. They say, which one of the following physical quantities is a measure of the inertia of a body? Right, so here we don't really need to think that much, right? So in this case, we know that mass is actually the measure of a body's inertia, right? So that is the answer. Right, number two, they say the distance between the center of two planets, P and Q, is R. They say the mass of planet P is twice that of Q, okay? So if we were to, take the mass there, we know this should be 2m if this is m, right? Now they say, consider the statements regarding the gravitational force exerted by the planets. They say the force will always be attractive, right? That's very true, right? So statement one is absolutely true, right? You can hear the thunder outside because it's raining, right? So they say the force exerted by P and Q is twice that exerted by Q on P. That is not correct, because remember, according to Newton's 3, if body P exerts a force on body Q, then body Q will exert an equal but opposite force on P, right? So in this case, number 3, they say the force that the bodies exert on each other is independent of their masses. That's not true, because remember, Coulomb's law Newton's law of universal gravitation does depend on the mass. So number 3 would not be correct. They say the force exerted by P on Q is equal in magnitude but opposite in direction to the force that is exerted by Q on P. This is absolutely correct. Okay. Now they say which statement or statements is or are true. All right. So we know in this case it should be statement 1 and statement 4. So the correct answer there should be C. Right, I hope that you got that. All right, let's go on to the next question. They say in 1.3, a ball is thrown vertically upwards and it returns to the starting point, right? Which one of the following statements regarding the rate of change of velocity? Now remember, when we talk about rate of change in velocity, right, we are referring to the acceleration of the ball, right? So acceleration is the rate of change in velocity, okay? Right, they say which one regarding the rate of change of velocity of the ball is true, right? So its direction for the upward and downward motion are different. That's not true. Remember that gravitational acceleration will be the same. It will always be vertically downwards. They say it is always directed downwards during the motion. All right, this looks true. B looks to be true, right? But let's check the others. They say it is 0 at maximum height. That is absolutely not true, okay? They say it is in the same direction as the velocity of the ball. This is not true, because when the ball is going up, the velocity is upwards, but the acceleration is downwards. Okay, it may be so on its way downwards, but it's not always the case. So obviously, the correct answer in this case is B. Okay, right. And then the next one, they say a vehicle is moving horizontally at a constant velocity on a frictionless path. They say the kinetic energy of the vehicle is K, and the magnitude of the momentum is P. Right, they say the speed of the vehicle can be given as, right? Now, in this case, I want you to note, ladies and gents, right? So when we look at momentum and the kinetic energy, so we know that kinetic energy, they said we can represent it as K, right? So you know that this is going to be half multiplied by m, right, times v squared, okay? Right, but we know that we P is equal to m multiplied by v. So what I can actually do is to say, well, this is half m multiplied by v multiplied by another v. So you can see how mv can actually be made into p. So this is equal to half multiplied by p multiplied by v, right? Okay, so this is equal to k. So they want us to find the velocity, right? So that means that we're going to have to divide by half p in both instances, half of p, right? So that cancels that. So v would be equal to, so I'm just going to complete it over this side. So v, now in this case, I want you to note we've got a half at the bottom. So I can multiply it by 2 at the bottom, but whatever I do at the bottom, I do at the top, right? So in this case, that will be given by 2k over p. All right, so in this case, that would be D, that would be our correct answer. And so in this case, that is how the cookie crumbles. Right, let's go on to 1.5. They say we've got the engine of a car does work W, right? To increase its velocity from 0 to V, right? Now, I always like, expressing that as an equation or a formula of sorts, right? So it means that the work done, remember, is equal to the change in kinetic energy. So this is going to be half m, right, times, now notice our final velocity in the first instance where work was w, our final velocity was v squared, our initial velocity was 0, right? So that means that w is equal to a half mv squared, okay? Right, now they say the work done by the engine to increase the velocity from v to 2v. Now I want you to note in this case, so it means we need to get the new work done, right? Let's call it work done new, right? In this case, the final velocity, so this is going to be half m, right? The final velocity is 2v, so that would be 2v squared minus, in this case, v squared, right? Now put that in brackets so that you remember that the entire 2v is actually squared, right? So this will give me a half of m, right? That will be into 4v squared minus v squared. And in this case, this will give me a half m into 3v squared. Right? Now, if I want to try and represent this in terms of W, you can see how this will actually become, right? So remember that multiplication is commutative, meaning that you can change the order of multiplication. The answer is still the same. So this is the same as 3 into half mv squared, right? But remember half mv squared, we call that W. So this will be 3w. That would be the answer. So it means that our answer there should be C. I hope you get that, right? All right, so the next question, they say a taxi sounds its hooter, I guess it was supposed to be its hooter, whilst it is moving at a constant velocity away, right? So here's our taxi. Right, it is moving away, so we assume, let's say it's going there. Right, so it's moving away from a listener. So suppose that here's our guy, with some detector there, right, listening to this taxi moving away. right? They said compared to the sound waves detected, right? So remember, in this case, the sound waves will be stretched, whilst on this side where it's moving towards, the sound waves will be compressed, right? So they said compared to the sound waves detected by the taxi driver, remember the taxi driver will actually hear the actual frequency of the taxi, right? Right, the sound waves detected by the observer has a greater, now note in this case, it will have a greater wavelength, right? So the wavelength will be longer, and the frequency in this case should be actually much less. So most definitely it will have a greater wavelength. Keep that in mind, right? As it's moving away, the wavelength is greater, so that the frequency in this case becomes less. Okay, right, I hope that makes sense, ladies and gents. Right, the next question, 1.7, right? They say sketches 1, 2, and 3, right, not drawn to scale, are different ways in which 3-point charges rather are arranged, right? So in this case, they say the charges are identical in magnitude and the distance d between the charges is the same, right? So here we are. We've got the 3 that are arranged in 1, 2, and 3. Now, they say to us, in which of these sketches will the magnitude of the net electrostatic force experienced by Q, right? All right, so all right, so they say experienced by Q, positive Q, in this case, be the largest and smallest respectively. Okay, now in this case, I want you to please remember. All right, so in the first instance, right, so the 2 charges will exert a force, right, in the same direction. Okay, so another one in the same, so it will be a force of attraction. So let's just say that Q, okay, will exert, okay, positive Q rather, will experience a force, okay, let's say force F in this case, right? Now it will experience, due to this charge here, right? Let's call it force F between Q and Q. Right, now notice once you double the distance, this distance now is going to be 2d, right? Now note that the force becomes a quarter, so it will be F over 4, so it will be a much smaller force in this case, right? So this will be F over 4, all right? So it will be 1 1/4, or in this case you can say that's 5 over 4, right? Of F, okay? Right, now if you look at this one, the 2 forces are actually exerting, the 2 charges rather, are exerting a force of equal magnitude but in different directions. So what will be the net force here? The net force will actually be 0, so it will experience a force of F in that direction, another force F in that direction, right? So in this case, it would mean that that force would actually be 0, right? The net force. Right, and let's talk about arrangement 3, right? So it will experience a force in that direction, force F in that direction, right? So what happens? It means that the net force will actually be in that direction there, right? And remember, to get that force there, you take the square of the hypotenuse, right, equal to the sum of the squares of the other 2 sides. So it means that F net, okay, will be, or F net squared will be equals to F squared plus F squared, and that's 2F squared, okay? And so it means that if we take the square root, it will be root 2 of F, okay? Now, you can already see how this force here will be the greatest, right? Square root of 2 in this case gives you about 1.4 something, right? Whereas 5 over 4 is definitely, so that will give us what, 1.25. In fact, we can check it out, right? Root 2, that's 1.4, you can see that. And 5 over 4 rather, 5 divided by 4 will give us 1.25. Okay, so remember, we said root 2 is 1.14 and this one is 1.25. So definitely this is a much greater force. Well, not much, but it's a greater force, right? So remember, they said they are looking for maximum and minimum. So it's maximum. In this case, the largest is at 1, okay? And the minimum is at 2. So in this case, it means our correct answer will be at A. This is a very interesting multiple choice question, I must add. Right, let's go on to the next question. They say to us, we've got 3 resistors, X, Y, and Z, that are connected as shown in the circuit below. Right, they say if the power in X, right, is P, then the power in Y is, okay? Right, so remember, when we talk about power in this case, of course, we're going to compare that power, all right, to the amount of current. So let's just suppose that the resistors are the same, so that's R, R, and R. So we know that power is I squared R, right? So definitely in this case, let's say the current that's passing through there is current I, right? So what does that mean? It means that the current will split into 2, which is I over 2 and I over 2 respectively, right? So that would be the power on X, right? But now when you talk about the power on Y, right, that would have the current there is I over 2, right? But remember, you square that, multiplied by R. So that means that it's going to be I squared R over 4, right? So it means it will be the power in X divided by 4. So it's going to be P over 4. Remember that the power in X was called P. So definitely the answer would be B, right? That's P over 4 there. Right, as we go on to almost the last one, right? They say the graph below shows the relationship between maximum kinetic energy, that's Kmax, of the photoelectrons rather, and the frequency of incident photons during an experiment on the photoelectric effect. Right, so they say to you the point labeled G, right, on the graph represents the. Right, so I want you to remember this, ladies and gents, right? So this would represent actually the work function, okay? So that would actually represent the work function. Remember that work function is energy, right? So in that case, that would be minus the work function over there. Whereas right there at the, well, x-intercept in this case, this is where we get the threshold frequency, right? That is what we get over there. Right, and then the last question, they say which one of the following graphs best represents the relationship between the maximum kinetic energy of the emitted photoelectrons and the intensity of the incident light when a light is shone onto the metal surface, right? Now, remember, when we talk about intensity, we are talking about how bright the light is, right? So, in this case, when you increase the brightness or you decrease the brightness, that has absolutely nothing to do with its kinetic energy. Remember, the only thing that changes the kinetic energy of the bulb, in this case, would be its, it would be the frequency, right? So if you change the frequency, then it would change the kinetic energy. So the intensity, as it increases, the kinetic energy would remain the same. So it means our answer there should be B. All right. I hope that makes sense, ladies and gents. Right. I'll be giving you even some more examples or questions as the week goes by, knowing that most of you will be preparing for your physics exam. All right. Otherwise, I'll see you guys next time. Sharp, sharp.